In this video, I'm going to show you how to create plots of acceleration versus time, velocity versus time, and position versus time. And I'm also going to discuss how these three plots relate to each other. So let's first look at acceleration versus time. Now, in this plot, let's assume acceleration is constant. So that means a plot of acceleration versus time will just be a straight line. A straight horizontal line, the green line in this figure. The acceleration is constant. Let's say it's 2 meters per second squared. It doesn't increase, it doesn't decrease. If we go down one step, we have velocity versus time. Now, because the acceleration is constant, it means that the velocity will increase at a constant rate. So velocity will be a straight line, and it will be a straight line that increases because acceleration is positive and constant. You can also see that by remembering that A is dv dt. So the slope of the velocity time plot is dv dt, and that is A. So A is constant. That means dv dt must be constant. So that means v versus t must be a straight line. Otherwise, it won't have a constant gradient. So I've indicated here on the vt plot dv in the y direction and dt in the x direction. And that gradient stays the same along the vt plot because acceleration is constant. Note that if acceleration is not constant, then the vt graph will not be a straight line. Now, let's go down one step and we say position versus time. Now, you will remember that velocity v is ds dt. So, velocity is the slope of the position time plot. So, if we look at our velocity time plot, we see velocity is not constant. It's constantly increasing with a constant acceleration. So, velocity versus time is a straight line with a positive gradient. And because the velocity increases over time, that means the slope of the position time graph must increase. V is not constant, meaning the STT is not constant. So that is why our position versus time plot isn't a straight line. It increases in gradient all the time. So if you take a certain point on the ST diagram, let's say in the middle of the time axis, right at the bottom, and you draw a line vertically upward, you will find a certain slope on the ST diagram. That slope will be the same as the velocity if you extend that line upwards. And that slope on the velocity curve will be the same as the acceleration if you extend the line upwards. So we'll look at an example now, and that'll make this more clear.